Hello everyone, this is Gagan Acharya and in this video I will be presenting on fundamentals of CFD and my final project on 2D analysis of F1 car aerodynamic. Computational flow dynamics CFD is a numerical technique used to simulate how fluids move and interact with surface. It solves the Navier-Stokes equations with the fundamentals of conservation of mass, momentum, and energy by dividing the domain into many small control volumes using finite volume method. CFD workflow includes creating the geometry, generating the mesh, setting up boundary conditions and physics model, running the solver, and finally post-processing to visualize velocity, pressure, and flow patterns. It is said that 80% of the manual effort goes on geometry generation and mesh, especially on the mesh. Higher the mesh quality, the higher accurate the result will be. So our manual effort is more focused on geometry generation and mesh. So the finer the mesh, finer the result. CFD is used in almost every engineering field: automotive, aerodynamics, aerospace design, HVAC flow studies, chemical mixing, manufacturing process, and even biomedical simulations like blood flow. It has a wide range of applications. CFD is important because it reduces the need for physical prototype, making it cost effective, save times, and speed up the design cycle, and gives high accurate prediction of complex flow behavior, making it an efficient tool. It also drives innovation and connects engineering, physics, mathematics, and computing, making it an interdisciplinary subject. There are many CFD softwares in the market: ANSYS Fluent, OpenForm, COMSOL, StarCCM Plus, SimScale. But ANSYS is industry standard, widely used because of its validated physics model, easy workflow, strong documentation, and excellent parallel computing. My project focused on 2D aerodynamic modeling of a Formula One car using ANSYS Plane to understand flow behavior around the vehicle. In F1 car, aerodynamics determines downforce, drag, grip, cornering speed, and overall stability. Even small improvement can significantly affect race performance, so aerodynamics matter a lot in F1s. My objective in this project is to stimulate 2D airflow around F1 car, develop a high quality mesh, and analyze drag, lift, and aerodynamic efficiency. Also, I will be analyzing two different mesh, one finer and the other not that fine, to see how the result goes. Also, my model will be the F1 car model will I will be designing on SolidWorks and then export that to Design Modular in ANSYS Fluent. Okay, this is my SolidWorks model of F1 car. So we will design SolidWorks model car and take it to ANSYS Design Modular and design CMS. This is SolidWorks where we will be where I have designed a F1 car model. So this is my F1 car model and this is how it looks. So look at this, it's a closed maze or a closed body. So it has been closed from all sides. To check that, you can see around and then click on shaded sketch contour and it gives a shaded region over here. If the body is not closed, then look at this, I like remove this line just to make it unclosed. So once I delete, the shaded region is gone. And now look at this, it doesn't have a shaded region though it is clicked on shaded sketch contour. So to that again I like click on the line and make it a closed one. So again, the mesh, again the color or the contour is appeared on the figure. So this is how I designed the project. And after that, I saved this file as IGES. Make sure your file is on IGES format so that you can run the one. So once I save the file, I'm running it on running as ANSYS. Now this is the ANSYS screen on your laptop. So you'll click on Fluent, and then you'll be on this screen. So click on the right click on the geometry, go to the properties. Since we are doing a 2D analysis, so click on 2D over here. So once you click 2D on this, go to the geometry and click new design modular geometry. Now you will be on our design modular screen. So this is the design modular screen. Click on XY plane, sketching, and then click on setting, grid, snap, and 2D. So major grid, we are using 1 meter, and minor stepper is 10 right here. So now I click on Z axis, that's it. So we are on our designing page right now. So after this, we will click on file, and there is import external geometry file. So click on this and the naming f1 2d model.igs. Remember, we make it on igs, and then we imported the design, and now we need to click generate. So the model is generated on design modeler. After this, we will be creating a CMS. So click on sketching, go to arc by center. Now make sure you are on center and make an arc through this. So you click on the center and then upper part, and then view on the side. So there is a C point, so click on it. Once it is, the CMS is clicked. Now draw a rectangle by 3 points. Click on the point, exact point. Look there, it's P over there. So you need to click on that. So P. Okay. And the other will also show the P so that it's the exact point. And now the third point for the rectangle. Okay, this is how we created the CMS. Now I will be dimensioning the CMS. So general, and then click on the time. So R1. So my CMS radius will be 4.5 meter. So now it's bigger one. Make it small and say okay. Right here, our rectangle length will be 12 meter. So that's the length we are using for the length. So once it is done, now go to modify, trim the middle line right there, click on it. So once you click, the line disappears. So now you have CMS and the outside side of the rectangle. So you don't, your body of the car is not divided. So you will remove that one. So this is how we design the CMS. Now after this, click on concept, surface from sketches, click on sketch one. Now look at the sketch, the yellow region, that's the sketch one. So now apply. Now right here, add material, and then on surface, create generate. So your surface is generated. Once the surface is generated, click on create boolean and unite. So that's changed into subtract, and now you'll get target body. So the target body is whole CMS body. So click on that and apply. And the tool body is the car body. So zoom, I click on that, also zoom to make sure it's car body only. So apply. So once it is done, look at the boolean there. So create generate. Okay, now it's on the board, and it's a boolean now. After this, we click on body path and then make it fluid so that it's a fluid one right here. Okay, since the geometry is now created, making it a fluid, so generate. Okay, that's how we create this geometry. Of this is the geometry right here. Of this, we'll go back to the, okay, this is all the geometry that we created. Of this, we'll go over here. over the project main window right here. Okay, so we completed the geometry, so there is a tick mark on it. After this, we'll be generating math, but before that, let us save the file as save as, and I name the file as on desktop as F1 right here. Sorry, CFD F1 2D analysis. That's the file name that I saved on. Okay, now the progress. It's saved now. Now after this, I click on the mesh to open the mesh section of the gun. So this is the mesh area, and it's taking a bit of time to load over here. Right in here. Okay, we got the mesh. That's the geometry that we have designed. So right here, this is how we are going. So in this, we are going to do with triangular method first. So click on the method and select the geometry. So entire CMS is the geometry, so it will apply over there, one body. And now at the method, we will be clicking triangles. That's it. So once it is done, click generate mesh or update. You can do any. So generate mesh. So okay, right here. So the progress, and it will give a click mark, and this is how triangular method only. So look at this, it's not a fine mesh, so we'll be working on it more. So we click on A's and then again select whole body of the F1 car to make all the edges. So make sure you click left click on the mouse and then move around so that all the edges of the car are selected. Make sure you zoom in and see all the if all the sections of it are selected or not. Here I zoom in more to see if the section are selected or not. Oh, I missed all the geometry. Again, select all the screen all around. Select left click on the mouse and then move around so that you click all the areas. There. Okay, my one small part is remaining and I click on it. Okay, that's how I select all the areas. Now, after this, right click on it and now insert sizing and look at this element size. Look, it's 0. So let's change it. Now we are on the element size screen. First of all, we are changing capture count to no and then making it stop. So number of division, no, I'm confused on this, so hold on for a while. Okay, we are not doing with numbers, we are going with element size right here. So once I click element size, to make it this finer one, we are using 0.01 as element size right here. And then behavior as hard. Okay, it's done now. Look, it shows the slicing over there. So once it is done, update the mesh with generate mesh. Okay, now it's working on generating the mesh. Okay, it's generated. Now when we click mesh over there, so this is how it looks right now. So still the mesh is not that fine and the sizes are not that good. Now we were working on it. So we will click on the mesh and then use the refinement as 2. So for that we click on refinement, apply whole body and refinement as 2. Once you do that, again click on that, generate mesh. Fine. Alright. Once the mesh is generated, okay, now click on mesh and see how the mesh looks. Click. Okay, this is how it looks. since we have like a big element size, so it's not looking that good. So I'm changing the mesh element since the inner surface or the edge surface looks good now. Just to check. Okay, since the element size is 0.1, so that's the element size that I'm using on this one just to make it fine. And now generate mesh. Now the mesh is created, and now I'm zooming in to see how the mesh is on the edges of the F1 car. Right here, the mesh looks good, and it's smaller in the end and increasing outside, so that's look pretty good. Now this is the one, and now I'll check on the edge sizing and name the outer C section as inlet. Yeah, inlet. Okay. Now the outer side we name it as mm, outlet. Right here, outlet. All right. After this, we'll select to the edges of the car to name the body of the car. So right here, I click left of my mouse and drag all around to select all the edges of the F1 car. So I'm selecting all the edges possible. So make sure you select all the edges. Do not leave any edges, as it would be an error on your calculation. So right here, what I did is like left press the key and move around the F1 car to check if everything is selected or not, and then I zoom it to check whether it is doing good or not, and it looks good. After this selection, I right click on and name it as F1 body 1. That's how I name it. Okay, that's only the one that we did over here. Once it is done, I set the project so that I don't miss anything of this. I just check around to see how the body looks. So I already named the section, create the mesh. Now I'm ready for this setup. Just seeing the mesh, if how it looks. Generating the mesh. Okay, after this, we are here on setup. This is the setup screen, double precision. Select 4 on this. 1, 2, 3, 4. Okay, start. So we are on the setup screen now. So this is how it looks. So make sure you are on transient model. This is the one that we are working on. So click on general. So we are setting up, it's on the transient model. So not the steady one. So we'll be selecting transient one. Okay, that's done. Now select materials. Now we'll go on materials one. Okay. Oh, so first let's go on model. So our model is K epsilon, realizable, standard wall function. That's okay with this. So press OK. I did this one. And then we'll go on materials, fluids, select aero here, and then change, create, close. All right. After this, we'll go to the boundary condition. Okay, inlet. So since it is a F1 car and the measure of the F1 car speed is 210 miles, so we'll use 90 meter per second. That's the standard for our car speed. Now on solution method, second order upwind, and transient formulation also on second order implicit function. Okay, second order drop point, and then first transient to second order implicit. Okay, that's done with solution method. And now initialization. In initialization, we'll be using hybrid initialization. That's okay right here. And then need to click initialize. Okay, then. And once it is analyzed, you will see solution animation right there. Click on it and we're working on it. So let's name it as velocity. And everything is okay right here. So time step and now new object contour. Since it is velocity, so let's name it as velocity right here as well. Oh, okay, let me write velocity contour so that it would be easier for our video to look on. Okay, the velocity counter is already made. So let me click on, it's already the velocity counter. So let me click on solution animation. Now we'll be doing of pressure. So I'll write pressure over here. Okay, pressure contour. So once I write that pressure contour, new object, contour, and then this is already pressure, so I'll name it as pressure right here. And save and display, close. So it's over there and then close it. Okay, I close it. Since it's already done right here, and I'm also still zooming it to see how it looks. Okay, now pressure, okay. And this is how it is done. Now, once it is done, now run the calculation. So to run the calculation, I'm using time step of 0.05 and number of time step as 3. Max iteration 40 per time step and calculate. Okay, this is how the calculation started right here. Once the calculation is started, you have nothing to do with, let it be complete up to 100%. So this is the calculation going on. I'll skip the video to 100% calculation after this. So this is how I check in between. Okay, the calculation is about to be 100% now. Once done, click on animation, playback, and then you can see how the velocity control look like. Press on velocity control, and you need to animate that. So click on video file. Okay, you can use the, yes, you need to understand this, use stored view. So if you do the use stored view, it will give whole image. But if you want to expand one, so you expand this, click on playback now again, and then remove the use store view from here so that you'll get a bigger view of the car. And now after this, velocity counter and video file and write it. So now the video is writing. I'll skip forward for a while. Once it's done, now it's done for the pressure counter. Okay, we click on the pressure counter and it's already right there on the frame. So pressure counter and write. Now the pressure counter will also be recorded. All right, all done. So after this, we'll click on report and see how the analysis goes. So here are different analysis things over here. I click district phase, histograms and all that. So fluxes, surfaces, and then I'll click on forces and see how the forces looks on the car wall right there. So I'm trying to click car wall. Okay, remove this and a car wall print. Okay, so the car wall net forces. Look, the pressure force right on the car wall is 16,358.917 Newton. Viscous force, total force, and coefficient pressures are shown in the screen. Now I'll click on statistical and see the facet average of car wall. I want feed variable as static pressure and compute. Okay, the average facet values is of the pressure, static pressure is 8655.1667. That's it. So you can change overall and see the other different variables right here. That's how we done, and I see the velocity it would be a zero because it's not moving in the car, it's not moving, only the wind is moving. So the car wall velocity is zero. So when I click the new one, so that's it all. So the how to look the videos. So click on that one, go to FFF, right click on Fluent, and you'll see the animation video right there. So I name it as pressure contour. So you can see the pressure contour right over there, and then open with Windows Media Player. So I open it and see the video right here. So this is the pressure contour, static pressure and pressure. That's on in the figure right there. Okay, I play it again so that you can see a very slight changes of the pressure at first. And this is the video of static pressure. Now I'm looking for velocity counter video right there, and I try to play it like this and it doesn't work. So need to do it again with open with Window Media Player. So make sure you open the video with Window Media Player. So this is the zoomed video of velocity magnitude of F1 car right here. Right. So if you see at the beginning, there is slightly change and then it remains the same overall throughout the session. Okay, that's it. Okay, this is the one that I completed. Now, for the second one, I want to see a different mesh. So I use the same geometry by clicking, pressing and bringing it to the other one. And now we have the geometry now. So for mesh, we are using a new mesh. So click on the mesh now. So we are using here the mesh, the same one, but everything is same, but we are not using the refinement on this so that we'll have a different one. So I use the triangular method, update the mesh, see how the mesh looks. After this, I clicked on the edge sizing and clicked the all the body of vehicle F1 car, and that I did before as well. So I am having problem in selecting this. So selected. So all the sections are selected except this. So once I zoom it again, it's all selected now. Now I'll use the incising and then element size to 0.0, 0.1, not 0.01. Okay, that's what I used before. Now capture curvature to no, and then soft to hard. Okay, here we go. So that's how we clicked on update the mesh. Okay, now the mesh look like this. So we are not using the refinement on this one. So once it is done, I make the element size to 0.5 to see how the mesh looks. Okay, this is the mesh that we are working on, making it a not that fine one. So this is what we are using for our second mesh analysis. So after this, it's done, and then just to make it more not fine mesh, we like I kept the edge sizing to 0.1. So look, it's a bigger, so we have a bigger section over there. So now naming the outer shell as outlet, sorry, inlet, and the outer shell as outlet, and the body of the car as F1 car. So it's selected now. No, not yet. Okay, done. Naming it as car wall. Okay, now done with the mesh. Now we'll move to the setup. Start, move to the setup, and then start. Right here, we are on the setup screen. Okay, let's make it the same one. The transient. Still K epsilon reliable external wall. I kept the same, all the settings same. So I'm doing a bit faster right here so that it's the same setting that we did before. So making a change close. And then inlet as same component and direction. And now 90. We'll make it 90 as we have been applying the same one for the other as well. After this, we'll go to the residual monitors and make it 1 equal to the power minus 6. All the setting to 1 e to the power minus 6. Okay, that's done. After this, we'll go to initialization. Okay, first method. Okay, second order, everything second order MP set. That's it. After this, we'll press hybrid initialize just to confirm if 90 millimeter is the inlet or not. So hybrid. Now you cannot see the calculation activities right here because I have an initialize. Now initialize will show the simulation animation. Name it at velocity low mesh, and then the same thing, new object, click on over here, write velocity on it, right click velocity, and then you'll see over there the velocity one. The mesh doesn't look good right there, you can see over there. Okay, that's done. Again, now for pressure, low mesh. Okay, pressure, low mesh. Okay, pressure is already there. Save and display. You can see the video over there. So now close it, and pressure, that's okay. Pressure low mesh. Okay, done. Now we'll run the calculation, making it the same 0.015, 300, and 40 iteration per minute, and all are the same. So now, just to confirm everything is okay, now done, calculate. Okay, now okay, it's running the calculation right now, and then calculation is complete. I skipped the video in between. So as we only see the thing that we need right here is the counter of static pressure and the counter of velocity. Right there, look at the pressure one right here. It doesn't look that even, like it's not showing that big pressure on it as it is on the finer mesh one. And also the drag velocity is like not that good quality image. So now just saying the video right here, and okay, that's it. Now I already said use store view just to see that. Now zoom it, remove the stored view so that you can get the one that you have keep over there. And now velocity, this is the velocity lowness. Okay, that's it. This is the pressure one. Okay, analyzing the videos now. Playback, pressure low mesh. It's look good. Now playing it just to see how it looks. All right. To see the vectors right here, I saw how the airflow is showing over here, and that's how it shows over here. So it shows the pressure, core, and vectors. Now once it is done, now let's go to the other one. So it will have the same geometry, same maze, and now we'll have a different setup. So we'll be using double precision for, and in this we are only changing the velocity of the car, so velocity of the air. So in this also it will be the same transient model. Everything is same except the velocity. So it will be k epsilon, realizable, standard wall, and then materials used is air as it was before, closed. Now boundary condition right here in the inlet, it will be like 40 meter per 60 meter per second, and then the other all the parameters are same throughout the process. So this is the one. Once it is done, the solution method, I use the same second order, and second order for everyone. The monitors and the 1 e power minus 6, everyone. 1 e power minus 6. Okay, that's done. Now we'll go to the initialization, click hybrid initialization that we did before solution animation, like we are looking at the animation. So right here, I'll name the animation as velocity. New object counter, so it's a velocity one, so I can like velocity right here, and then it should be velocity right there. Save and display, compute, close. So there is already shown the velocity, so I'll select the object as velocity. Okay, done. Now again on the other one, pressure, vector, sorry, counter, and pressure right there, and save and display, compute, close. Pressure, okay, so it's already done, so it should have a unique name, so I should like name it on animation 2, and then it's done over here. So run calculation, everything will be same. 300 number of time step, 0.05 and 40 iteration per time step. Okay, calculate. Once the calculation is done, the result of the calculation, it started the calculation from here. So 1% calculation is completed. Now we'll see the animation on a different speed. Also, we'll see the vector of the forces. This is a finer mesh, so it should have a good analysis of the pressures on the body. So that's the one that we are looking of the finer mesh. So it's look good on this rather than the other mesh. So now animation playback. And animation 1 and animation 2, these are the name of the animations right here. So this is the one for the first one, and this is the second one. So this is the one for the second one. So
this is all the pressure, all the velocity. So once it is right, we'll get the video. That's it. Okay, this is how we can analyze F1 car 2D analysis. And we here did like 3 projects. One with the finer mesh at 90 meter per second, one with the low mesh at 90 meter per second, and one with the final velocity one. So changing the velocity to 60 meter per second on the last one. So here the average facet value is -447. That's it. Thank you for watching.